Number 12 on this power series problem set given by professor at Princeton University. These were past exam problems, supposedly. Okay, so number 12, we're going to do part A first in this video and then part B in another video. So we're asked to find a Taylor series about 0 of ln of 1 plus x squared. So depends on the school you went to, but sometimes in lecture you might have went over the Taylor series of ln of 1 plus x. So if you had memorized it, great. Directly use it and save a bunch of time to get just simply get the power series of this. Okay. Otherwise, it might be wiser to find the Taylor series of ln of 1 plus x first, and then find the Taylor series of ln 1 plus x squared. Okay. So instead of directly finding the Taylor series by taking derivatives of this guy. Okay. Because you can imagine the higher order derivatives of ln of 1 plus x squared will become more complicated because you need product rule, quotient rule, whatever. Okay. And chain rule. So you can just imagine it will be more complicated versus a 1 plus x. If you use chain rule, it'll just be linear. Or it'll be a constant because derivative of 1 plus x is 1 versus derivative of 1 plus x squared is 2x. So you can, that's why it'll be probably more complicated. So this is where your experience from the previous course from taking derivatives comes into play. You can't just forget about that stuff. Okay. Now, so with that said, this is what I did. I found a Taylor series of ln of 1 plus x. Honestly, I don't have this one memorized. Maybe I should as a tutor, instructor, whatever, but I just quickly found it. So by the brute force way. So we take derivatives. So zeroth derivative is just the function itself. First derivative is 1 over 1 plus x, which we can write as 1 plus x to minus 1 power. Second derivative, we do the power rule first, and then the chain rule. Chain rule derivative of 1 plus x is just 1. That's why it's easy enough. Okay, that's why I said if it was 1 plus x squared, derivative of the inside would be 2x. So then you'll start having to use product rule. So that's, again, just comes from experience and previous knowledge. Okay, so third derivative, fourth derivative, I won't explain it, just power rule again. Okay, so evaluate the derivative at 0 because that's the center of the power series that's given. Okay, that's 0, 1, minus 1, 2 factorial, and minus 3 factorial. Okay, I won't go over the details there. Hopefully you see the pattern now. So we can write it as, what did I do first over here? So obviously there's a change in sign, okay? And we can start from 1, by the way, because the 0th term is 0. So it's a change in sign. And then it's n minus 1 factorial for the nth derivative as 0. That's the general pattern. X to n over n factorial, that's just from the definition of the Taylor series itself, Maclaurin series itself, okay? So you can simplify too, because n minus 1 factorial, or sorry, n factorial is n times n minus 1 factorial. You can simplify it to this. This is the Taylor series of ln of 1 plus x, centered at 0. Okay, so if you had memorized this, you can just directly go from here. Otherwise, you have to spend a couple minutes to derive it, which I did here. And again, I don't have this memorized. Okay, so now we just use properties of functions, replace the x with the x squared. So the Taylor series is summation as n goes from 1 to infinity minus 1 to the n plus 1, x to the 2n over n. And that's the answer. Hopefully this was helpful. Please check out part B when it posts if you're interested. And yeah, hopefully see you in that video. Bye.